motion notes. I want you guys to see that. I really want to talk about displacement. Actually, I'm going to pause this recording because they've already got this one. Okay, so we are here, and we're going to just have a little discussion that you need to have straight. So the three things when we're discussing motion that we really need to know: position, so it determines where the particle is located. So it determines the location on an x-axis at a time t. Then we have our velocity. Determines how fast the position is changing. Okay. And velocity also is going to give me a direction. Bless you, by the way. Moving to the left, moving to the right. Okay, so velocity is going to give you a direction. And then acceleration it determines how fast the velocity is changing. So as we measure position, could just be like in feet. Velocity could be in like feet per second. And acceleration is going to be in feet per second, which would be feet per second squared. So I mean, it's not always feet, and it's not always seconds. But in like whatever your time or whatever your position, you're going to have the squared with the acceleration for the time. Okay, so let's see if we can fill these in, and then we'll start today's notes. If x of t represents the position of the particle along the x-axis at any time, then fill these in so that the following statements are true. Initially means when what is 0? T. When time is 0. Okay, so see if you can do 2 and 3. Okay, so at the origin means where what is 0? X. The position. You may want to write x of t, right, which is the position. If you write x, I'm fine. If a particle is at rest, what's equal to 0?
Velocity.
Velocity. Is that okay? Okay, try 4 and 5. Okay, what'd you get for 4? To the right. And 5? already filled in. Guys, 6, 7, 8. 7 years old. Okay, what is 6? Position. Right? Change in position over change in time. Average velocity. Do I even see a velocity formula anywhere? No. What happens if I see it? What do I get to do? I get to walk. You remember? Yeah. Yeah, I do. Okay, so 7 is just telling us, so go ahead with 8. What you guys get for 8? Velocity. Okay, try 9 and 10. No, I want Allie too. Allie, what's 9? Yeah. And what's 10, Allie? Uh-huh. Good. Okay, so on number 11, now we're going to see this total distance, okay? So if you want to find the total distance, can we just do the end minus the beginning? No, because sometimes we may change, places. Like I may be going negative or positive, and we said we got to see all those pieces. So on number 11 here, says one way to determine total distance traveled over a time interval is to find the sum of all the absolute values of the differences in position between all resting points. Oh, okay, well this just wants me to find the total distance traveled on this interval. And I'm going to let you guys use your calculator, okay, again, just for time purposes. So I know that I could have some things that could be negative and some things that could be positive. And I would have to take that total distance absolute value and add it with that total distance, right? To get the overall if I'm kind of traveling back and forth. Does that make sense what I'm saying? What we were discussing? Okay, so let's see if we can get this done and find the total distance. And I want you guys to see if you can figure it out with your partners. What do you first have to go find? All the what? Okay, so all the x-intercepts. Find all the x-intercepts. Start finding x-intercepts. That's not going to help. Everybody good with how I got the velocity formula? It was a basic power rule, right? From position. Okay. And I'm looking from 0 to 6, basically. So I need to find where I'm at 0, where I'm at, what's the next thing here going on? 3, and where I'm at 6. So let's go find those. And am I plugging them? Sorry, I already gave you the hint. I'm plugging them back into my position. I want to know what are those positions. So for 0, what did you get? 4. For 3, what did you get? -5. And for 6? 22. Okay, so how far did we travel here? 9. How far did we travel here? 27. So how far did we travel overall? 36. Did it say what we were in? So units, whatever it is. Yes. How did I get what? I plugged them. This is my position. I guess I should have said x of 0. So you're always putting s. Sorry about that. Okay. Drake? Because we know the derivative of position is velocity. Derivative of velocity is acceleration. Okay. Okay, is this okay? You could do this? Now, if all you did was do s of 6 minus s of 0, and you got 22 minus 4, which is 18. Whoops. What does that represent? That's displacement. Okay, this is your total distance. Okay? Okay. Yeah. That's going to be our math lectures this year. Huh? Or you can have your pie and eat it too. I don't like you anymore, Brar. Oh, I just said that on the recording.